Hi, this is Dr. Rapala for Quality, Safety, and Healthcare. This is week 6, and we are going to talk about technology, healthcare, and information technology and informatics in healthcare. And basically, there's a robust science behind all of this that we don't always consider when we're implementing technology. So let's take a quick look. So first of all, human factors is the study of factors and the development of tools. It's really how a human interacts with the environment. And another word for human factors is ergonomics. You may have heard some office type of adjustments to desks and things. It's the same thing. And actually, there's a huge body of study around this uh, that really is transferable to healthcare. We haven't always taken the time to do that properly in our rush to solutions. So today we're going to take a breath and look at this, and hopefully you can think about these things when you get into practice, because it can be a low-tech solution where something is arranged, it can be something high-tech like the electronic healthcare system. So the first concept we're going to talk about is cognitive selective attention. And one of the things that you'll notice, and this is something that's useful in analyzing healthcare and healthcare error, is a controlled flight into terrain. That's when a pilot flies a perfectly good airplane into a mountain, the ground, what have you. They go back and analyze everything, and the alarms are fine, everything's working, everybody's trained, but what happened? Well, many things can happen, and it isn't necessarily the pilot's fault. It's just how our brain is wired. So what causes a pilot to drive into a mountain when everything's working perfectly? So there's several things that can happen that can make our attention waver to something else. So first of all, consider salience, which is attentional capture. It's like an alarm. So if there's an alarm going off in the cockpit, there's a lot of false alarms. We've heard about that in the workplace. Maybe the pilot's desensitized to it. So maybe the alarm was going off, but it wasn't paid attention to because it went off, every 10 minutes. So alarms are useful, but they have to be implemented in the correct way. And we do see that again in healthcare. Another factor that can cause this phenomena is effort. So if the pilot, the healthcare provider, has to make a concentrated effort to do something, that thing may not get done. So for example, let's say there's a quality improvement initiative to chart skin conditions for pressure ulcers. And instead of in the normal workflow, the caregiver has to go 3 or 4 different clicks to another place that's hard to find, really has to think about doing that. And in the space of a busy day, that may be one of the first things to go. So it's just a phenomena that, if it takes a lot of effort, it could get nosed out. Expectancy is another factor. So is it where you expect to find information? So for example, when the Alaris IV pumps were first implemented, and they capture every keystroke is captured, and they noticed that the 9 was being switched with the 1. And when the engineers looked at it, they realized that the keyboard wasn't set up like a telephone, and thus people were thinking telephone when they were entering the keystrokes, and they're causing errors, which I think actually is pretty sophisticated. It must be muscle memory, because I can't think of that many numbers. And then finally, how valuable is it to see the information? If people don't think the information is of value, and this happens a lot in healthcare, somebody has to chart something and they're not clear why, or document something. If it's not valuable to them, it may be something that is lost in the shuffle. The other thing that I think about a lot, and we really load on to our caregivers. And if you think of busy environments, either in the home, the hospital, hospice, lots of different places, our brain can only handle so many pieces of information. So our brain capacity is only 7 plus or minus 2 chunks of information at one time. And remember Dr. Ebright talking about stacking, where one person, you have all these things stacked up, something's got to give, and that's just the way our brains work. And I always think of my credit card number. I can never remember what my credit card number is. My kids can remember it. I can't, because that must be like the limit of my brain for chunks of information. But also time can uh, affect your memory, confusability and similarity, and then also attention. But this is when we're analyzing tasks or errors, and somebody says, oh, they should have done that. That's why you really have to take the environment into consideration, because there's only so much a human brain can handle, and we expect people to be super people. So moving into some of the definitions, healthcare technology is, and human factors applies to this all, but healthcare technology is more general devices, medicines, vaccines, all kinds of things developed to solve a health problem and improve quality of lives. Healthcare information technology is the use of information and communication technology in healthcare. And so HIT, which you'll hear both of these bounced around, and some people understand the differences and some don't. But HIT is a narrower definition, and quite commonly we think of the electronic health record, but it can also be things like um, the phones that nurses use, or the EICU, or any of those sorts of things. It can be things that the patient uses as well. So I just call your attention to this. ECRI is a wonderful organization. It is a nonprofit. It's not affiliated with really any profitable thing. It really looks at different hazards and risks. And every year they, among other things, publish the top 10 health technology hazards. And a lot of times we think of super fancy things, but if you look at their list, I think there's one on here where there it is, loose nuts and bolts can lead to device failures, and that's part of technology, making sure that the environment is safe. So I call your attention to this. They publish it every year. Usually organizations take this list and do an assessment within their organization to see where they are. And some of it isn't things that you come to mind right away, like surgical staplers, but they look at all, they have big databases, and they look at the technology risks. They work with the FDA, so they're able to produce these alerts. We don't always pay attention to it, but most good organizations somebody in the organization takes this hazard list and translates it into a work plan. So one of the things that's kind of interesting that's happened in my day is HIT has evolved from just the electronic application. It used to be that beds and vents and IV pumps didn't link to the electronic health record. Now they do, just over a short span of years. So now electronics is linking many aspects of care where it didn't before. So HIT is really expanding, so you can get messages from the bed, barcoding. You guys probably know better than I do what's going on out there. So HIT now has CPOE, decision support systems, but also the larger system around it. Now, HIT plays a key role in data collection, transmittal processing, display and storage, and it also hopefully saves some healthcare costs, improves outcomes, decreases errors. And we have seen, despite kind of the gloomy subject matter of this class, things like barcoding have decreased medication errors. We don't see transcription errors with bad handwriting as much. So there's some really good things that have come from the medical record, although there's still, of course, some things we have to pay attention to. This I'm not going to go over, you can take a look at, but here is the evidence that is actually positive for patient safety, and it makes me happy. However, there's things that can go wrong, and I'm not going to hit on this particular video, and you can. There are a few things that can go wrong. And here are the risk points, and you can read down the list: hardware, software, clinical content, interfaces, workflow, and communication. Years ago, one of my mentors said, I really worry about the electronic health record because instead of one provider not giving one medication or dispensing one, you have the risk of spreading to many different people, and that's true. So if something's put in the computer wrong, maybe with a code, it can affect the number of people maybe not getting crucial lab results and things like that. So there are quite a few risk points here when you look at it. There's also some contributing factors you can see. And here's actually the volumes. You see a lot of it is loss and delay of value data that's reported in the databases. As many databases, this is things that are reportable to MAUDE, so it's probably just a tiny fraction. Well, I'm sure it is because it's just 241 reported incidents, but it does give us an idea of what's happening out there. Now, nursing informatics is a science that integrates nursing information and knowledge, another important area. And this diagram is super important. I think about this a lot because you can have data, you can have information, but you really have to process it to create knowledge and change. I think this particular diagram was developed for informatics, but I think it is usable in almost everything that we do. So we have a lot of data. How do you turn it into actionable knowledge? In the Lavin article, there's kind of an interesting Jesuit model that's used, so I'm just pointing that out. And finally, there's an article in the Lavin article, a way to kind of look at assessment, diagnosis, outcome identification, planning, implementation, and evaluation, which I think is a very useful model. You can look to see what Dr. Gandhi says about technology, because sometimes you think, oh my gosh, this is a huge headache. But I think her particular take on this is right on target. So I hope everybody is having a great week. Email with any questions. This again is a really interesting area that we live every day, and understanding more of the science behind it can really help us. See you guys later.